to have a measure of variance? The answer is to determine the spread of the data, to determine the consistency of a variable, to determine the number of data value that fall within a specified interval in a distribution, which means Chebyshev's theorem used in inferential statistics.
Okay, next we move to the question 2.
With reference to table 1, find mean, mode, and median of the following data. Firstly, we find mean. To find mean is we need to add all the numbers in the table, then we divide it by 20 because it contains of 20 data in the table. So we get 47 over 20. Then the answer is, next, move to the mode. Mode is the highest frequency. So from the table, we can get the number 1 and 2 as the highest frequency because it shares the same frequency, which is 5. Next, median. Firstly, we need to arrange all the numbers in increasing order. Then we cross it. After that, we got the two numbers in the middle. Then we divide it by 2. Then we get the answer as 2. Last question. Which measure of center is best here? Explain your answer. So my answer is mean because it uses all the data value, varies less than the mode or median, and the other answer. Thank you.
Let's proceed to the question number 3.
Question 3, number 1. Determine the quartiles for the data. We have to arrange the data in ascending order. Then we need to find quartiles 1, quartile 2, and quartile 3 by using quartiles formula. And the answer is number 2. Obtain and interpret the interquartile range. By using IQR formula, we will find the answer. So the answer is, then in this question, we have to find and interpret the 5 number summary. We have to find minimum, quartiles 1, median, quartiles 3, and max. So the answer is number 4. We need to calculate the lower and upper limits. We just take the range and width formula to calculate lower and upper limits. Then we arrange step by step in class limit. So the answer is number 5. We have to identify potential outliers. By using outliers formula, the answer is the last question. We have to construct and interpret a box plot. Just draw the box plot by reference to question 3. So the result is,
Let's go to question number 4.
Specify the mathematical symbol used for each of the following descriptive measure. The first is sample mean. The mathematical symbol is x bar. The formula is. Second is sample variance. The mathematical symbol is s squared. The formula is. The third is sample standard deviation. The mathematical symbol is SF. The formula is. The fourth is population mean. The mathematical symbol is mu. And the formula is. The fifth is population variance. The mathematical symbol is sigma squared. The formula is. The sixth is population standard deviation. The mathematical symbol is sigma. The formula is.
And lastly, question number 5.
The population mean. The formula of population mean is mu equal to total of x divided by the number of population. So we have to total all the enrollments data divided by 8, and we will get the answer 17.29 because the answer must be in 2 decimal places.
Next.
Compute a population standard deviation. The formula is square root total of x minus mean power of 2 divided by the number of population. Insert all the data that we have in that formula and we will get the answer 6.4636, but we have to round the answer to 2 decimal places and the final answer is 6.46. Specify the standardized variable z corresponding to x. Okay, the z-score formula is x minus mean divided by standard deviations. The x is total all the enrollments data, then we minus the mean and divided by standard deviations. So the answer is 18.7322.
Question number 4 asks for the mean and the standard deviation. The mean will be 0 and the standard deviation will be 1. This is stated in the properties of standardized values. For question number 5, we start off the box plot by making the numbered line. And then we make the box by using the quartiles we searched in the previous question. Then we search for the highest and lowest number and mark it in the plot. Lastly, we draw the lines between the numbers outside the box plot.